today's session, and our new topic is DC circuit theory, and our subtopic is Kirchoff's laws. And before I progress, kindly subscribe to my YouTube channel, that is Agnes Tamir. I have uploaded a variety of content pertaining electrical principles. Like, comment, and share. Let's look at our learning outcome. And by the end of the video, you should be able to 1. State Kirchhoff's laws, and 2. Determine unknown currents and voltages in a DC circuit. By the end of the video, you should be able to state Kirchhoff's laws, that is Kirchhoff's current law and Kirchhoff's voltage law. And also, you should be able to calculate unknown currents and voltages in a DC circuit. Let's start by working on learning outcome number 1, whereby it's stating Kirchhoff's laws, and we shall start by stating Kirchhoff's current law, and it states that the total current flowing into a junction is equal to the sum of current flowing out of the junction. Kirchhoff's current law states that the total current flowing into a junction is equal to the sum of current flowing out of the junction. Let's look at Kirchhoff's voltage law, and it states that the total voltage in any closed loop network is equal to the sum of the voltage drops within the network. Kirchhoff's voltage law states that the total voltage in any closed loop network is equal to the sum of voltage drops within the network. And that marks our learning outcome number 1, and I believe we have achieved it, whereby we were supposed to state Kirchhoff's laws, and we have done that by stating Kirchhoff's current law and Kirchhoff's voltage law. Let's look at learning outcome number 2, whereby we are supposed to look at determine unknown values for current and voltages in a DC circuit. Let's look at example number 1. Example number 1 states that using Kirchhoff's law, find current flowing through each component, given that R1 is equals to 2 ohms, R2 is equals to 3 ohms, and R3 is equals to 6 ohms. This is our example number 1. And let's start to solve that problem. We shall start by drawing the circuit diagram. I have already drawn it for you. And this is our supply voltage, that is 18 volts. R1 we have been told is 2 ohms. R2 we have been told is 3 ohms. And R3 we have been told, or we have seen, is 6 ohms. Now, using Kirchhoff's current law, we have seen that current flowing into a junction is equal to the sum of the current flowing out of the junction. The total current flowing into a junction is equal to the sum of current flowing out of the junction. Let me just repeat. We have seen that using Kirchhoff's current law, that the total current flowing into a junction is equal to the sum of currents flowing out of the junction. We can see that I1 is flowing into this junction here. That is whereby shall divide into I2 and I3. Therefore, the sum of I2 and I3 will give us the total current I1. And that is our equation number 1, whereby I1 will be given by I2 plus I3. Let's look at loop 1 and develop more equations. Using loop 1, that is the current that is flowing through this loop here in a clockwise direction through R1, R2, and back to the source. We know that current flows from a high potential to a low potential. that is from positive to negative. Therefore, this is our positive terminal. Therefore, current will flow in this direction and back to the source. Therefore, as we have seen that current flows from a high potential to a low potential. Therefore, this will be positive and this will be negative. This will be positive terminal and this will be the negative terminal of the resistor. Positive, negative, positive, negative. Therefore, this one, we shall have a voltage drop here and another voltage drop here. Why do I say voltage drop? When we move from a high potential to a low potential, that is a voltage drop. When you move from a low potential to a high potential, that is a positive or a rise voltage drop. Sasa, now we know that using Ohm's law, voltage is given by current multiplied by resistance. Using Ohm's law, we know that voltage is given by current multiplied by resistance. Our current through this component here will be given by I1 multiplied by R1. R1 is 2. The voltage through this component will be given by I2 multiplied by R2. So let's look at develop the equation for this loop, that is from the positive terminal, that is from the source all the way and back to the source. Sorry. So this will be positive 18, positive 18. We are moving from a high potential to a low potential, that is a voltage drop. Therefore, our voltage drop here will be 2 multiplied by I1. So it will be negative 2 I1. We are moving from a high potential to a low potential, that is from positive to negative. So our voltage drop in this component will be given by R2 multiplied by I2. And our R2 is 3. And when we multiply by I2, we'll have 3 I2. Sorry, this is supposed to be 3 I2, not 3 I. Let me just rectify that. Sorry for the mistake. Just a minute. Yes, supposed to be positive 18 minus 2 I1 minus 3 I2 is equals to 0. Why? We know that Kirchhoff's voltage law states that the sum of all voltage across a closed loop is equals to 0. Therefore, we equate our equation to 0. Now, we can sort this by moving 2 I1 and 3 I1 into this direction. Therefore, we shall have 2 I1 minus 3 I2, not I3. Sorry, I don't know why I made such a mistake. I'm sorry for that. Just a minute, I rectify. I'm really sorry. Sorry for that. I am done. So we shall have 2 minus 3 I2 is equals to 18. This is our equation number 2. Let's look at loop 2. This is our loop 2. We also moving in the clockwise direction from R2 all the way to R3. Remember we said that this is positive, negative. Now we are moving from negative to positive. Sorry, we are moving from negative to positive, positive to negative. I believe we are seeing that. So for this case, our equation will be from negative to positive. So we shall have a voltage rise, that is 3 I2. We are moving from positive to negative. So this one will be a negative or a negative voltage drop. So we shall have, let me just write it here. At loop 2, we shall have 3 I2, positive 3 I2 minus 6 I3. Why 6 I3 minus? We have said that this is a positive voltage drop, and these are negative voltage drop. So this one, why is it positive? Because we are moving from a negative to positive. So we are moving against current. And this one moving the direction of current from positive to negative. So this one gives us negative 6I3. Let's continue. Is equals to 0. That is our equation number 3. Now let's rewrite the equations. We have equation 1 was I1 is equals to I2 plus I3. Equation 2 we have seen is I2 2I1 plus 3I2 is equals to 18. And equation 3 is here, that is 3I2 minus 6I3 is equals to 0. Now, using equation 1, we can see that I3, we can see that equation 2 and 3, we have I3 here, this is I2, I3, so we have to change, either to use I1, I2, or I2, I3. But let's just work with I1, I2. I think it will be easier for us, but in any way it can still work. So it will depend with you. So you can also pause the video and try to work through the calculation and see whether we shall have the same answer at the end. So we can see that I3 will be given by I1 minus I2. I3, if you move this 2 in this direction, we shall have I1 minus I2. So I3 will be given by I1 minus I2. Now, this equation number 3, we can now replace I3 with I1 minus I2. Therefore, our equation will be 3I2 minus 6 into I1 minus I2 is equals to 0. 3I2 minus 6, when you multiply I1 minus multiplied by 6, you shall get 6I1. This is negative I2 multiplied by negative. Negative and negative, it will be addition. So we shall have plus 6I2 is equals to 0. We have like terms here, that is positive 3I2 and positive 6I2. When we add these two, we shall have 9I2 minus 6I1 is equals to 0. This is our equation number 4. Now let's progress and see. Let's substitute equation 1 and equation 4 using substitution method. Equation 1 is here and equation 4 is here. Using equation 1, let 2I1 be equal to, when you move positive 3I2 into this direction, we shall have 18 minus 3I2. Positive, we can move in this direction, it will be negative. So we shall have negative 3I2. So I1, 2I1 will be equal to 18 minus 3I2. Let's divide both sides by 2. So divide by 2, divide by 2. Therefore, I1 will be equal to 18 divided by 2 is 9, and 3 divided by 2, let's just work with the fraction instead of a decimal point. We shall have 3 over 2 I2. That is our equation 2. Let's now substitute or replace this equation into equation 3. We know that I1 is equal to 9 minus 3 over 2 I2. So we replace it in this equation. Let's progress and see. Let's find I1 using equation 5, the one that we have just seen. Sorry, we are here. I believe, I'm sorry. What is happening here? Yeah, we are here. We are substituting equation 1 into equation 4. And this is our equation 4 we have just seen in the previous slide. It's here. Remember, I said you can as well pause the video and work. So when we replace I1 into this equation, into equation 4, equation 4 was 9I2 minus 6I1 is equals to 0. 9I2 minus 6I1 is equals to 0. So 9I2 minus 6I1. So this bracket should be here. Sorry. This bracket should be here. Yes, should be like that. Sorry. Also, this should be here. Let me just do the minor changes. I believe it's just because of it's okay now. So we have 9I2 minus 6I1, and we have seen that I1 is equals to 9. I1 is equals to 9 minus 3 over 2 I1 is equals to 0. So 9I2 minus 6 times 9 is 54. Negative multiplied by positive, we have positive. Negative by negative, it's a positive, sorry. So we shall have 6 times 3, it's 18 over 2 is equals to 0. Let's divide by 2 here. We shall have 9. And this 54 we move to the other direction so that we can sum up the like terms. So 9I2 plus 9I2 is equals to 18I2, which is equals to 54. This side here will be equal to 18. I2 is equals to 54. Let's divide both sides by 18. So you divide by 18, by 18, by 18, by 18. So 18 and 18 will cancel. We shall have I2 is equals to 54 divided by 18 is 3. And because SI unit for current is amperes, our answer will be 3 amperes. I2 will be equals to 3 amperes. Now, let's find I1 using equation 5. Where is our equation 5? Equation 5 is here. Equation 5 says that I1 is equals to 9 minus 3 over 2I2. That is our equation 5. This is supposed to be equation 5. Just a minute. Don't worry. These are just minor changes that appear while you are typing. Yes, so it's okay. Let's find I1 using equation 5. And our equation 5 is here. Not here. This was equation 4. Sorry, I have done the wrong thing. That was equation 4. Yes. Equation 5 was 9 minus 3 over 2 I2. Yeah, this is supposed to be 3 over 2. Supposed to be 3 over 2 I2. Yeah, it's correct now. So we have seen that I2 is equals to 3 amperes. So we are replacing I2 by 3 here so that we can look for current current 1 or current through R1. Therefore, we shall have 9 minus 3 over 2 multiplied by 3. 3 by 3 is 9. Divided by 2 is 4.5. Therefore, we shall have 9 minus 4.5. Our current one will be 9 minus 4.5 is 4.5. So current one will be 4.5 amperes. Remember we said in our equation number 1 that I1 is equals to I2 plus I3. Therefore, I3 will be given by I1 minus I2. We already have I1 and we have I2. Therefore, our I3 will be given by 4.5 amperes minus 3.0 amperes. And our I3 will be given as 1.5 amperes. We can as well prove and see whether our answer is correct. we have seen that one current one is 4.5. So we want to see whether this is true. So we can open our bracket, that is 2 multiplied by 4.5 minus 3 multiplied by current 2 was 9. Our answer should be equal to, just a minute, we want to prove and see whether our answer is correct. Our current one is 1.5 and our current 2 is 3. So let's go back to our circuit and see. Just a minute. 2 multiplied by, this is supposed to be current 1. How did I make those mistakes, really? I believe I had a typing error. 1, I1, supposed to be I1. Okay, it's okay now. At your free time, you can as well check whether whatever you are having here is correct. We have seen that our current one is 4.5 and our current 2 was 3. Therefore, when you add those voltage drops, should be equal to this voltage drop here. This also is supposed to be positive. I don't know why I made these mistakes. Okay, it's supposed to be that way. So when you multiply 2 by 4.5 plus 3 multiplied by 3, your answer is supposed to be 18. Let's just confirm that. We have seen that 2 multiplied by 4.5 plus 3 multiplied by 3. We are supposed to get 18. Yes, that is what I'm getting. That means that this section is correct. Now let's look at the other section. We have seen that I2 is 3 and I3 is 1.5. So when we add those two, we are supposed to get 0. So 3 multiplied by 3 minus 3 multiplied by 6. Was it not 3 but 1.6, 1.5 minus 1.5 multiplied by 3 by 6, sorry. You should get 0. That is what I'm getting. It means it's correct. You can as well prove at your time, at your own time, but is this the end of our, that is the end of our example number 1. And my class cannot end without an assignment. Here goes your assignment number 1, and it should be submitted in the next class. Assignment number 1 says that using Kirchoff's laws, calculate I1, I2, and I3. This is your I1, I2, and I3. I can see I never gave you the values, so let me write the values. R1 is equals to 2. R1 is equals to 2. Sorry, we are here. Let me add the values for you so that you can be able to calculate without any problem. So R1 is equals to 2. Is equals to 4 ohms. R1 is equals to 4. We write very fast. Just want to add so that we may be in a position to work it out. We cannot work while it is in unknown values. So we said that R1 is equals to 6 ohms, and R2 is equals to 8. Now let me just give you the correct values so that you may be in a position to work it out. Yeah, I have it. R1 is equals to 3. R2 is equals to 4, not 8. And R3 is equals to 12. 12 ohms. Let me insert the symbol. So work on this assignment here and submit in the next class. We have two assignments, that is assignment number 1. So assignment number 1 says that using Kirchoff's laws, calculate I1, I2, and I3. And these are the values for R1, R2, and R3. And R1 we have seen is 3 ohms, R2 we have seen is 4 ohms, R3 is 12 ohms. So it is now workable. You can work using these values. Let's look at assignment number 2. And assignment number 2 says that using Kirchhoff's laws, determine current flowing through 6 ohm resistor and power dissipated in 4 ohm resistor. That tells you that you have to look for the currents flowing through 5 resistor, 4 resistor, and 6 ohm resistor. Then after getting the current that is flowing through this circuit, now you use the current flowing through resistance 4 ohm resistor to calculate power. How do we get power? Power is given by voltage multiplied by current. Power is given by voltage multiplied by current. This question here, you have to recall on what you were taught about series parallel circuit, because this resistor is connected in series, whereas 4 ohm resistor and 6 ohm resistors are connected in parallel. So using that knowledge on how to calculate series parallel resistance, you use it to calculate the voltage drop in this section and the current that you have got to get the power dissipated. We have said that power is given by current multiplied by voltage. Remember, just to highlight, current flowing in a serial circuit is assumed to be the same, but in a parallel circuit, current is assumed to be different, but the voltage is the same. So the voltage that will be flowing this direction, or this 6 ohm resistor, will be the same as voltage that is flowing through the 4 ohm resistor. So the first thing that we'll do, we'll have to calculate the voltage drop that is flowing in the 5 ohm resistor. Then you take the supply voltage minus the voltage drop. The balance will be the voltage that will be shared across the 6 ohm resistor and the 4 ohm resistor. Thank you. That is the end of our session. And remember to subscribe in my YouTube channel. That is Agnes Tamir. May God bless you. May He empower you as you continue in your learning. Thank you so much.